According to the internet, the mean length of a radio song is 235, and that's in seconds. So that is our random variable here for part C and D is x, right? It's x. And x equals the length. The length, not the mean length. That's going to be x bar. But we have this random variable. That's the length of the song. Okay, and we have a mean of 235, and we have a standard deviation of 45. Part C says, if n equals 100, what would the z-score be for x bar equals 224? And then part D, which is very much related, what is the probability of getting a sample mean of less than 224 with 100 songs? Compute and interpret. So part C, we have to find the z-score of x bar when n equals 100. So part C, we're going to have to use this formula, which comes from the central limit theorem. That's one of the results of the central limit theorem. We're going to standardize the sample mean. So this is going to equal 224, which is the value that we want to standardize, minus the population mean. And then we're going to divide by 45. No! You divide by 45 divided by the square root of 100 because of the central limit theorem. And this equals negative 11 over 4.5, which means that the amount of variability, the standard deviation in the sampling distribution of sample means when n equals 100 is 4.5 minutes. No, seconds, because we're talking about seconds here. That is less than it was when n equaled 4. Compare those results. Check it out. So the z-score is going to be negative 2.44. And in part D, you want to know the probability of a z-score like that and then interpret it. So in part D, we want the probability that the sample mean is less than 224 when n equals 100, which is the same thing as the probability that z is less than negative 2.44. So we want to find that probability, which we can just go to the standard normal table. We can also use one of the applets, which I'll show you how to use right now. And here we are. We're at David M. Lane's personal website. And you can mess with the inputs here to calculate an area. This is going to tell you the area underneath the curve in the standard normal, or if you prefer, you can put in any mean and standard deviation you want. I'm going to go with the mean and standard deviation as given here because that is the standard normal. I'm going to change above to below. Then I'm going to change 1.96 to negative 2.44. Then I'll press enter. And then there's the answer, 0.0073. Not a lot of area out there. Not a lot of area out there. Not a lot of area out there at all. This is equal to a very important probability. If the true mean is 235, then the chances, by the central limit theorem, of getting a sample mean of less than 224 seconds, consider all the different possible means that are less than 224 seconds, the probability of that when your sample size is 100, it's not very likely. In fact, the probability is 0.0073. So I'll be somewhat relaxed here in the explanation of, or the interpretation, I should say, because we want to talk in radio business terms, right? So, hey, the chances of the mean of 100 songs being less than, not negative 2.44, because that doesn't, what, right? Nobody knows what z-scores is, radio language here. Less than 224 seconds is nothing to worry about. Now, I don't know about you, but maybe I'm walking around, I'm like, oh no, I got 100 songs here and I'm going to calculate the sample mean. Oh man, I hope it's not, I hope the mean here of this 100 songs that I'm going to play isn't less than 224 minutes. And the people in charge would say, the statistician or you guys would say, listen, don't worry about it. It's only like a 73 in 10,000 chance. So move on.